Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ACB equals to 100 degrees, angle ABC equals to 30 degrees. We also know that AD equals to BC, and we want to find out the value of this angle ADC. So we will start with the first method. In the first method, we will define side AC as A, that is to say, side AC equals to A units in its length, and we will also define side BC as B. That is to say, side BC equals to B units in its length, and it is given us in the question that AD equals to BC, and we define BC as A. So from this equation we will derive that AD also, we define BC as B, BC equals to B, and therefore from this equation we will derive that AD equals to also to B. So we can write here that AD equals to B, so first of all I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle so we can write down that in any triangle if we have triangle ABC, that could be any triangle, this is triangle ABC, and we know that side BC of triangle ABC equals to A units, and this angle equals to A degrees. Side AC equals to B units in its length, and this angle equals to angle B. It equals to B degrees in its length, in its size, and side AB equals to C units in its length, and this angle is angle C. Then, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. I'll repeat again. in any triangle, A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B, and we will implement the law of sines in our triangle ABC. So I will draw triangle ABC in a new page, and we will implement the law of sines in triangle ABC. So So this is triangle ABC. I copied it from the original drawing. First of all, we will find out the value of this angle BAC. We know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, the sum of its angles is equal to 180 degrees. So here 30 degrees plus 100 degrees plus the size of angle X must be equal to 180 degrees. Here we will subtract 130 degrees from this equation, and we will get that X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that angle X is equal to 50 degrees. So we can substitute angle X by angle that equals to 50 degrees. And now we will implement, first of all, AC equals to A according to our definition, and BC equals to B according to our definition. So according to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. We will divide this equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. So we found out that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. I will draw triangle ADC, this triangle, and we will implement the law of sines in this triangle, triangle ADC. But first of all, we know that angle BAC equals to 50 degrees. We have already found out that this angle BAC equals to 50 degrees. So, therefore, if angle BAC equals to 50 degrees, so if we define this angle as theta, if angle BAD equals to theta, then angle DAC must be equal to 50 degrees minus theta in order to complete the sum of those two angles to 50 degrees. This angle must be equal to 50 degrees minus theta because of the fact that 50 degrees minus theta plus theta will be equal to 50 degrees. Exactly as we have already found out that angle BAC equals to 50 degrees. Okay, so now we'll find out the value of the angle that we are looking for, that is actually angle ADC. Okay, so if we define angle ADC as angle X, we note that the sum of the angles in triangle ADC must be equal to 180 degrees. That is to say, angle X plus 100 degrees plus 50 degrees minus theta must be equal to 180 degrees. The sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 150 degrees from this equation, and we'll get that x minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add theta to this equation, and we will get that angle x equals to 30 degrees plus theta. So we'll substitute angle x by 30 degrees plus theta. Now I will copy triangle ADC to a new page, and we will implement the law of sines in this triangle, triangle ADC. Okay. So this is triangle ADC. I copied triangle ADC from the original drawing, and we will implement the law of sines in this triangle ADC. According to the law of sines, A over sine 30 degrees plus theta will be equal to B over sine 100 degrees. So here we will divide this equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that according to equation number 2, A over B A over B equals to sine 30 degrees plus theta over sine 100 degrees So according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. And according to equation number 1, A over B A over B equals to sine 30 degrees over sine 50 degrees. So we will create equation number 3 that states that A over B according to equation number 1 equals to A over B according to equation number 2. Okay, I repeat again. Equation number 3 states that A over B according to equation number 1 equals to A over B according to equation number 2. So we get that A over B according to equation number 1 is equals to sine 30 degrees over sine 50 degrees. And it equals to A over B according to equation number 2. And A over B according to equation number 2 equals to sine 30 degrees plus theta over sine 100 degrees. So I'll repeat again. So here, equation number 3 states that A over B according to equation number 1 equals to A over B according to equation number 2. So here, we will cross multiply this equation number 3, and we will get that sine 30 degrees times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Here we will use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a and according to equation number 3, sine 30 degrees. Sine 30 degrees is 1 over 2, so we will substitute sine 30 degrees by 1 over 2. And sine 100 degrees, according to this trigonometric identity, that sine 2a equals to 2 sine a cosine a, sine 100 degrees will be equal to 2 sine 50 degrees times cosine 50 degrees, that equals to sine 30 degrees plus theta times sine 50 degrees. 2 over 2 is 1, so 2 will get cancelled. And we have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And what is left after we cancel sine 50 degrees from equation number 3? What is left? It is actually, in this side of the equation, we have cosine 50 degrees equals to sine 30 degrees plus theta and we also have the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. So here we will use this trigonometric identity in order to find the value of cosine 50 degrees in terms of sine. So cosine 50 degrees, according to this trigonometric identity, will be equal to sine 90 degrees minus alpha, and alpha here is 50 degrees. So cosine 50 degrees equals to sine 50 degrees, 90 degrees minus 50 degrees is 40 degrees, so it is sine 40 degrees. So we actually found out that cosine 50 degrees equals to sine 40 degrees. And so we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees according to this equation. So we will do it and we will get that according to equation number 3, cosine 50 degrees, here it is sine 40 degrees, and it equals to sine 30 degrees plus theta. Sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we'll subtract 30 degrees from this equation, equation number 3, and we'll get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees. And the angle that we are looking for is actually angle ADC. And as you can see in the drawing, angle ADC equals to 30 degrees plus theta. So angle ADC that we are looking for equals to 30 degrees plus theta, and theta equals to 10 degrees. So angle ADC equals to 30 degrees plus theta, this is 10 degrees. 30 degrees plus 10 degrees is 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. Okay, so the final answer to the question is that the value of angle ADC that is actually equals to 30 degrees plus theta is equal to 40 degrees. Angle ADC equals to 40 degrees. Okay. Angle ADC equals to 40 degrees. So we finished with the first method. In the next step I will present to you how to find out the value of angle ADC, this angle, according to the second method. In the second method, we will extend side BC by a straight line, and then from point A we will draw perpendicular to the extended BC, so this angle is a right angle, it equals to 90 degrees, and this angle it is also a right angle. We will define the intersection point between the extended BC and the perpendicular from point A is point E. And we will also define side BC as point A. BC equals to A units in its length, according to our definition. And we will define line segment CE as X, and we will define line segment AE as Y. What is the value of angle ACE? The value of this angle, first of all, BC is a straight line because it is one side of a triangle ABC that is a straight line, of course. And we extended the straight line BC by a straight line. So BE will be a straight line also. BE still will be a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we define this angle ACE as Y, then if we focus on the upper side of the straight line BE, at point C, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus the size of angle Y must be equal to 180 degrees. I repeat again. On the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus Y must be equal to 180 degrees. We will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So angle Y equals to 80 degrees, so we'll substitute angle Y by 80 degrees. And it is given us in the question that AD equals to BC. Again, according to what is given us in the question, AD equals to BC. Okay, but according to our definition, BC equals to A. BC equals to A according to our definition. So from this equation, we will get that AD also equals to A. So we can write here that AD equals to A. In the next step, we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, tangents 80 degrees, will be equal to AE over CE. I will repeat again, on the right triangle, triangle ACE, this right angle, tangents 80 degrees equals to AE over CE. Tangents 80 degrees equals to AE over CE. But AE equals to Y according to our definition, so we'll substitute AE by Y. And CE equals to X according to our definition, so we'll substitute CE by X. And in conclusion, we got that according to equation number 1, tangents 80 degrees equals to Y over X. We will multiply equation number 1 by X, and we will get that according to equation number 1, Y equals to X tangents 80 degrees. In the next step, we will focus on the right triangle, triangle ADE. So in the right triangle, triangle ADE, first of all, we will define the angle that we are looking for, that is to say angle ADC or angle ADE as angle theta. So in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. I will repeat again. On the right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to Y according to our definition. So we'll substitute AE by Y. And we have already found out that AD equals to A, so we'll substitute AD by A. So according to equation number 2, sinus theta equals to y over A. Here we will multiply equation number 2 by we'll multiply equation number 2 by A, and then we'll divide it by sinus theta, and we'll get that according to equation number 2, A equals to y over sinus theta here we will substitute y by, we already found out that y equals to x tangents 80 degrees, so we'll substitute y by x tangents 80 degrees, and we will get a equals to y, and y is x tangents 80 degrees divided by sinus theta. So according to equation number 2, A equals to x tangents 80 degrees over sinus theta, while according to equation number 1, y equals to x tangents 80 degrees. Okay? So in the next step, we will focus on triangle ABE, the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. I repeat again, on the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. But AE equals to y according to our definition, so we'll substitute AE by y, and BE equals to A plus X. I repeat again, AE equals to y, BE equals to A plus X. Therefore, tangents 30 degrees equals to y over A plus X, according to equation number 3. Tangents 30 degrees equals to y over A plus X, according to equation number 3. According to equation number 1, y equals to x tangents 80 degrees, and according to equation number 2, A equals to x tangents 80 degrees over sinus theta. So we'll substitute A and y in this equation, equation number 3, by the values that we found for y and A in equation number 1 and equation number 2. and we will get the tangents 30 degrees equals to y according to equation number 1 is x tangents 80 degrees over a plus x, and a according to equation number 2 is x tangents 80 degrees over sinus theta, and we also have to add x, so we'll actually add x sinus theta. It is actually, we multiplied x by sinus theta and then we divide it by sinus theta, so we change nothing, because x times sinus theta over sinus theta equals to x. So here we will move sinus theta to the numerator, and we will get that according to equation number 3, tangents 30 degrees equals to x tangents 80 degrees times sinus theta over x tangents 80 degrees plus x sinus theta here we have x in the numerator and we have x in the denominator, so x will get cancelled and we know that tangents 30 degrees is 1 over square root of 3, so I write it down. 1 over square root of 3 equals to tangents 80 degrees times sinus theta over tangents 80 degrees plus sinus theta So here we will cross multiply equation number 3 and we will get that tangents 80 degrees plus sinus theta equals to square root of 3 times tangents 80 degrees times sinus theta. Here we will subtract sinus theta from this equation, equation number 3, and we will get that tangents 80 degrees equals to square root of 3 tangents 80 degrees times sinus theta minus sinus theta so here we will take sinus theta as a common factor from this side of equation number 3, and we will get that tangents 80 degrees equals to sinus theta. So sinus theta was taken as a common factor from this side of equation number 3, and inside the brackets, what is left from this expression? What is left? It is actually square root of 3 times tangents 80 degrees minus what is left from minus sinus theta after we took sinus theta as a common factor. What is left? It is actually minus 1. So here we will divide this equation by square root of 3 tangents 80 degrees minus 1, and we will get that according to equation number 3, sinus theta equals to tangents 80 degrees over square root of 3 tangents 80 degrees minus 1 So we actually found out that sinus theta, according to equation number 3, equals to tangents 80 degrees over square root of 3 tangents 80 degrees minus 1. We know that tangents 80 degrees equals to sinus 80 degrees over cosine 80 degrees, so we substitute tangents 80 degrees in the numerator and in the denominator by sine 80 degrees over cosine 80 degrees, and we will get that according to equation number 3, sinus theta equals to tangents 80 degrees is sinus 80 degrees over cosine 80 degrees divided by square root of 3, and here also sine tangents 80 degrees is sine 80 degrees over cosine 80 degrees minus 1. So we'll substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees. Okay. So here we have cosine 80 degrees in the numerator and cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and we will get that according to equation number 3, what is left from equation number 3 after we cancelled cosine 80 degrees, what is left, it is actually here in this side of the equation we have sinus theta that equals to sinus 80 degrees over square root of 3 sinus 80 degrees minus cosine 80 degrees okay. So here we will multiply the denominator by 2 and then we will divide it by 2, and we will get that according to equation number 3 sinus theta equals to sinus 80 degrees over 2 times square root of 3 divided by 2 times sine 80 degrees minus cosine 80 degrees divided by 2. So we actually multiplied the denominator by 2 and then we divided by 2, so it is allowable because we changed nothing. And we'll get that according to equation number 3, sine theta equals to sine 80 degrees sine 80 degrees over so the sine 80 degrees over 2 times here square root of 3 over 2 is actually cosine 30 degrees. So we'll substitute square root of 3 over 2 by cosine 30 degrees. And 1 over 2 is sine 30 degrees. So we'll substitute 1 over 2 by sine 30 degrees and we'll multiply it by cosine 80 degrees. So we have the trigonometric identity that states that sine A minus B equals to sine A cosine B minus sine B cosine A so we use this trigonometric identity in order to find the value of sine 80 degrees cosine 80 degrees minus sine 40 degrees times cosine 80 degrees. According to this trigonometric identity, sine 80 degrees times cosine 80 degrees minus sinus 30 degrees times cosine 80 degrees will be equal to sine A is 80 degrees and B is 30 degrees, so it is actually sine 80 degrees minus 30 degrees. Okay? So, according to equation number 3, we will get that sine theta equals to sine 80 degrees over 80 degrees minus 30 degrees is 50 degrees, so it is sine 50 degrees. So I'll repeat again. Here 50 degrees minus 30 degrees, 80 degrees minus 30 degrees is 50 degrees. So we found out that according to equation number 3, sine theta equals to sine 80 degrees over sine 50 degrees. But we also have the trigonometric identity that states that sine alpha equals to cosine 90 degrees minus alpha. So actually, according to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees, or sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that according to this trigonometric identity, that sine alpha equals to cosine 90 degrees minus alpha, we will get that sine 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sine 50 degrees by cosine 40 degrees in equation number 3, this equation, and we will get that according to equation number 3, sine theta equals to sine 80 degrees over, and sine 50 degrees equals to cosine 40 degrees, so we'll substitute sine 50 degrees by cosine 40 degrees. And here we'll use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. So according to this trigonometric identity, we will get that sine 80 degrees equals to 2 sine 40 degrees cosine 40 degrees over cosine 40 degrees. So here we have cosine 40 degrees in the numerator and in the denominator on this side of equation number 3. So cosine 40 degrees will get cancelled, and we got that sinus theta equals to sine 40 degrees here we add actually 2 in the denominator, but here we have 2 in the denominator of equation number 3, so 2 I didn't write it in the following expressions of equation number 3, so 2 is also here, and we have 2 also here, and we have 2 also here, and we have 2 also here. So 2 over 2 is 1, and we left only equation number 3 that states that sinus theta equals to sine 40 degrees, that is to say theta equals to 40 degrees. We found out that angle theta equals to 40 degrees. Angle ADC, that is actually angle theta, the angle that we are looking for, equals to 40 degrees. So according to the second method, we found also that the value of angle ADC that equals to theta equals to 40 degrees. So we finished with the second method. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of this angle ADC, I repeat again, wanted to find out the value of this angle ADC. And in the first method, we define AC as A, and we define BC as B, and according to what is given us in the question, we know that AD equals to BC. But according to our definition, BC equals to B. So from this equation, we will derive that AD also equals to B. AD equals also to B. And then I presented to you the law of sines. According to the law of sines, in any triangle, if this is triangle ABC, that could be any triangle. This is triangle ABC, that could be any triangle. Side AB equals to C units, side BC equals to A units, side AC equals to B units. This is angle A, this is angle B, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. From the law of sines, from this formula we will derive that A over sine A equals to B over sine B. And then we implemented the law of sines in our triangle ABC. I copied triangle ABC, this triangle, in a new page, and we implemented the law of sines in this triangle ABC. So this is triangle ABC. It is given us in the question that angle ACB equals to 100 degrees. It is given us in the question that angle ABC equals to 30 degrees. This is the missing angle. We define this angle as angle X, and we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, the sum of the angles must be equal to 180 degrees. That is to say, angle X plus 100 degrees plus 80 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we got that 180 degrees minus 130 degrees is 50 degrees. So we found out that this angle BAC equals to 50 degrees. Okay? We know that AC equals to A according to our definition. BC equals to B according to our definition. So we implemented the law of sines in this triangle. According to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. Here we divided this equation number 1 by B, and then we multiplied it by sine 30 degrees. So we got that A over B equals to sine 30 degrees over sine 50 degrees. I will repeat again that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay, then I copied triangle ADC to a new page, and we implemented the law of sines in this triangle ADC. First of all, we have already found out that angle BAC equals to 50 degrees. This angle that is actually angle BAC equals to 50 degrees. So if this angle equals to 50 degrees, and angle DAB equals to theta, then the rest, that is actually angle DAC, must be equal to 50 degrees minus theta, in order that the sum of those two angles will be equal to 50 degrees. This angle DAC must be equal to 50 degrees minus theta, because of the fact that 50 degrees minus theta plus theta equals to 50 degrees. That is actually the value of angle BAC. And angle BAC equals to 50 degrees according to what we have already found out. So if angle DAB equals to theta, then angle DAC must be equal to 50 degrees minus theta. So I copied triangle DAC in a new page. In this page, we know, although we have already found out that angle DAC equals to 50 degrees minus theta, this angle equals to 900 degrees, it is given us in the question, and we found out the value of this angle. The value of this angle, it is actually angle Y, or you can call it angle X, whatever. If we define this angle as angle X, then we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So this angle, that is angle X, plus 100 degrees plus 50 degrees minus theta, must be equal to 180 degrees, because of the fact that the sum of the angles in triangle ADC must be equal to 180 degrees. So X plus 100 degrees plus 50 degrees minus theta must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we got that X minus theta equals to 30 degrees, because 180 degrees minus 150 degrees is 30 degrees. Here we added theta to this equation, and we found out that angle X equals to 30 degrees plus theta. So we found out that this angle equals to 30 degrees plus theta. So I copied triangle ADC in a new page, this new page, and we know that angle DAC equals to 50 degrees minus theta, angle ACD equals to 100 degrees, it is given us in the question. And we just right now found out that angle ADC equals to 30 degrees plus theta. AD equals to B, because of the fact that AD equals to BC, AD equals to BC, and BC equals to B. Okay, AD equals to BC, according to what is given in the question, and BC equals to B, according to our definitions. From this equation, we will derive that AD equals to B. AD equals to B. So AD equals to B, AC equals to A, according to our definition. So we implemented the law of sines in this triangle, triangle ADC. According to the law of sines, A over sine 30 degrees plus theta equals to B over sine 100 degrees. Okay? Here we divided this equation number 2 by B, and then we multiplied by sine 30 degrees plus theta. We got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. Okay? And then we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So A over B according to equation number 1, it is actually sine 30 degrees over sine 50 degrees. And A over B according to equation number 2 is sine 30 degrees plus theta over sine 100 degrees. Sine 30 degrees plus theta over sine 100 degrees. Here we cross multiply the equation number 3, and we got that sine 30 degrees times sine 100 degrees equals to sine 30 degrees plus sine 50 degrees. We use the trigonometric identity that states that sine 2 theta equals to 2 sine theta cosine theta. So according to this trigonometric identity, we will get that sine 100 degrees equals to 2 sine 50 degrees cosine 50 degrees, and sine 30 degrees is 1 over 2. So in conclusion, we got in this side of the equation 1 over 2 equals to 2 sine 50 degrees cosine 50 degrees. 2 over 2 is 1, so 2 will get cancelled. So here we left only with sine 50 degrees times cosine 50 degrees, and it equals to sine 30 degrees plus theta times sine 50 degrees. We have sine 50 degrees on both sides of the equation, so sine 50 degrees will get cancelled, and we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. But according to the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha, we will get, according to this trigonometric identity, that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees, so we actually got that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in this equation number 3, by sine 40 degrees. We did it, and we got that sine 40 degrees equals to sine 30 degrees plus theta. From this equation, we will derive that 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation number 3, and we got that angle theta equals to 40 degrees minus 30 degrees is 10. So we found out that angle theta equals to 10 degrees. Angle theta equals to 10 degrees. And the angle that we are looking for, it is actually angle ADC. Angle ADC equals to 30 degrees plus theta. Angle ADC equals to 30 degrees plus theta. That is the angle that we are looking for. And theta equals to 10 degrees. So angle ADC equals to 30 degrees plus theta, that is 10 degrees. That is to say, angle ADC equals to 30 degrees plus 10 degrees. It means that angle ADC equals to 40 degrees. So we found out that angle ADC, the angle that we are looking for, equals to 40 degrees. We finished with the first method. Then I presented to you how to find out the value of angle x according to the second method. In the second method, we did a construction. We extended side BC by a straight line, and then from point A we drew perpendicular to the extended BC. So this angle is 90 degrees and this angle is 90 degrees, and we defined the intersection point from the extended BC and from the perpendicular from point A as point E. So the intersection point of the perpendicular from point A and the extended BC is defined as point E. And we defined AE as Y and CE as X. We found out the value of this angle. BC is a straight line because it is side of triangle ABC. We extended the straight line BC by a straight line, so BE will be still a straight line. And we have the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So this angle is 100 degrees, plus this angle, that is angle y must be equals to 180 degrees. At point the upper side of the straight line BE at point C, 100 degrees plus the size of angle y must be equal to 180 degrees. We subtracted 100 degrees from this equation and we got that angle y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that the value of angle y, the value of this angle y equals to 80 degrees. Then we focused, we know that AD equals to BC. It is given us in the question that AD equals to BC. But but BC equals to A according to our definition. According to our definition, BC equals to A. BC equals to A. So from this equation, we will derive that AD also equals to A. So we can write here that AD equals to A. Then we focus on the right triangle ACE. On the right triangle ACE, we know that tangents 80 degrees equals to AE over CE. In this right triangle ACE, tangents 80 degrees equals to AE over CE. AE equals to Y according to our definition. CE equals to X according to our definition. So we found out that tangents 80 degrees equals to Y over X. We multiplied this equation number 1 by X, and we got that Y equals to X tangents 80 degrees. Then we focus on the right triangle ADE. On the right triangle, this triangle ADE, we defined angle ADE, the angle that we are looking for, is angle theta. And we know that in the right triangle ADE, sinus theta will be equal to AE over AD. In the right triangle ADE, sinus theta equals to AE over AD, but AE equals to Y according to our definition, and AD equals to A. So in conclusion, we found out that sinus theta equals to Y over A. Sinus theta equals to Y over A according to equation number 2. And here we multiply the equation number 2 by A, and then we divide it by sinus theta, and we got that A equals to Y over sinus theta, but Y equals to X tangents 80 degrees. Y equals to X tangents 80 degrees. So we can substitute Y by X tangents 80 degrees. Okay, and we got that A equals to X tangents 80 degrees over sinus theta, and Y according to equation number 1 equals to X tangents 80 degrees. And then we focus on the right triangle ABE, the big right triangle ABE. According we know that in the right triangle ABE, tangents 30 degrees equals to AE over BE. Tangents 30 degrees equals to AE over BE. AE equals to Y according to our definition, and BE equals to A plus X. Okay, tangents 30 degrees equals to A over BE, A equals to Y, and B equals to A plus X. So in conclusion, we found out that according to equation number 3, tangents theta equals to Y over A plus X. So we substituted Y by X tangents 80 degrees, and we substituted A by X tangents 80 degrees over sinus theta, and we have to add also X. So X, we multiplied X by sinus theta, and then we divided by sinus theta, so we changed nothing. And then we moved sinus theta from the denominator to the numerator, and we got that tangents 30 degrees equals to x tangents 80 degrees times sinus theta over x tangents 80 degrees times x sinus theta. Here we have x in the numerator and we have x in the denominator, so x will get cancelled. And we also know that tangents 30 degrees equals to 1 over square root of 3 units. So we got that 1 over square root of 3 units equals to tangents 80 degrees times sinus theta over tangents 80 degrees plus sinus theta. Here we cross multiply the equation number 3 and we got the tangents 80 degrees plus sinus theta equals to square root of 3 times tangents 80 degrees times sinus theta. Here we subtracted sinus theta from this equation number 3, and we got the tangents 80 degrees equals to square root of 3 times tangents 80 degrees sine theta minus sine theta. Here we took out sine theta as a common factor from this side of equation number 3, and we got the tangents 80 degrees equals to sinus theta was taken as a common factor, so inside the brackets from this expression what is left, it is actually square root of 3 times tangents 80 degrees, and what is left from minus sinus theta after we took from it sinus theta as a common factor, what is left from it is actually minus 1. Okay, then we divided this equation by square root of 3 times tangents 80 degrees minus 1, and we got that sinus theta equals to tangents 80 degrees over square root of tangents 80 degrees minus 1. We know that tangents 80 degrees equals to sinus 80 degrees over cosine 80 degrees, so we substituted tangents 80 degrees by sine 80 degrees over cosine 80 degrees, and also here square root of 3 tangents 80 degrees is sine 80 degrees over cosine 80 degrees, and we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 1 after we cancel cosine 80 degrees, what is left is here in this side we have sine theta that equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. So here we actually multiplied the denominator by 2 and then we divided by the denominator by 2. It is allowable to multiply something by a number and then we divide it by the same number because we changed nothing. So we got here sinus theta equals to sinus 80 degrees. So we multiplied the denominator by 2 and then we divided the denominator by 2. Here we multiplied by 2 and here we divided by 2. So it is square root of 3 over 2 times sine 80 degrees, and cosine 80 degrees we divided by 2. Okay, here we multiplied by 2 and then we divided by 2, so we changed nothing. So we got that sine theta equals to sine 80 degrees times 2 times, here we have sine 80 degrees, square root of 3 over 2 is cosine 30 degrees, so we substituted square root of 3 over 2 by cosine 30 degrees, and we have also here sine 30 degrees, cosine 80 degrees, and 1 over 2 is sine 30 degrees, so we substituted 1 over 2 by sine 30 degrees, and the expression that we got, sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees, is similar to the trigonometric identity that states that sine A minus B equals to sine A cosine B minus sine B cosine A. So we can substitute our expression by sine A minus B. In our specific expression, A equals to 80 degrees and B equals to 30 degrees. So sine A minus B will be actually sine 80 degrees minus 30 degrees. So we did it, We substitute this expression by sine 80 degrees minus 30 degrees, and we got that sine theta equals to sine 80 degrees over 2 sine 80 degrees minus 30 degrees. Here 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we got that sine theta equals to sine 80 degrees over 2 sine 50 degrees, because 80 degrees minus 30 degrees is 50 degrees. Then we have the trigonometric identity that states that sine alpha equals to cosine 90 degrees minus alpha. So according to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. So we can substitute sine 50 degrees. Here we can substitute. We have sine theta equals to sine 80 degrees or 2 cosine 40 degrees. Okay, as you can see here, we substituted sine 50 degrees by cosine 40 degrees because of the fact that sine 50 degrees equals to cosine 40 degrees. Okay? And then we use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. So we can substitute sine 80 degrees by 2 sine 40 degrees times cosine 40 degrees. And in the denominator we have cosine 40, 2 times cosine 40 degrees. 2 over 2 is 1, so 2 will get cancelled. And we have cosine 40 degrees in the numerator, and we have cosine 40 degrees in the denominator, so cosine 40 degrees will also get cancelled. And we left only with, according to equation number 3, with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that angle theta equals to 40 degrees. So the angle that we are looking for, that is actually angle ADC that equals to theta, equals to 40 degrees. Angle ADC that equals to theta equals to 40 degrees. So in both methods, we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. Okay, thank you very much.